Percent yield, what is it and how do we calculate it? Let's look at a very typical stoichiometry problem. Here we have hydrogen peroxide breaking down into water and oxygen. And if given 100 grams of hydrogen peroxide, how many grams of oxygen can be formed? The method to solve this is to go from grams to moles to moles to grams. And the calculation would look like this: 100 grams of hydrogen peroxide converting to moles of hydrogen peroxide, then to moles of oxygen, then to grams of oxygen, should yield 47.03 grams. So our calculations say for 100 grams of hydrogen peroxide, we should get 47.03 grams of oxygen. Does this mean we will actually get 47.03 grams of oxygen? The answer is no. The calculation here assumes 100% efficiency. Every bit of this 100 grams is going to be converted into oxygen. In reality, no reaction is 100% efficient, and there's always a loss due to impurities, due to various factors in the experiment itself or the laboratory procedure itself. And so what is percent yield? First, a few definitions. The theoretical yield is the calculated amount of product expected using the balanced equation. So that is what we just calculated. This 47.03 is the theoretical yield, how much you could get based on the math on paper. This really assumes a 100% efficient process. The actual yield is the amount of product produced when the reaction is actually carried out, either in the laboratory or in industry, whatever it might be actually carried out in. And the percent yield is the ratio of the actual yield to the theoretical yield times 100%. So the ratio of the actual yield to the theoretical yield times 100%. The way I usually describe it is how much you did get compared to how much you could get times 100%. Pretty much the same way you would score a test or a quiz. How much did you get out of the possible number of points? So here's a typical percent yield problem. Here we're told that solid sodium bicarbonate decomposes when heated to form solid sodium carbonate, water, and carbon dioxide. So from that you can write the balanced equation. And then we're told when 80 grams of sodium hydrogen carbonate is heated, it produces 37.51 grams. This is the actual yield. That is the amount that you did get. And so to calculate the percent yield, we have to know the theoretical yield. How much could you have gotten from that reaction? That's a pretty typical stoichiometric calculation. We have to go from the initial reactant, grams to moles to grams to figure out how much we could get. So that is what this calculation is going to look like. Again, our initial reactant to moles of that reactant to moles of the product to grams of the product. And so the math says that if we start with 80 grams of sodium hydrogen carbonate, you should be able to get 50.47 grams. But again, this is the theoretical. That's assuming 100% efficient. And so to calculate the percent yield is just how much did we get compared to how much could we get times 100%. So again, it is the actual yield divided by the theoretical yield times 100%. And so this reaction would be 74.32% efficient. In other words, you're only getting about 3/4 of what you possibly could get. Imagine you running a business of producing sodium carbonate from sodium bicarbonate. If you're getting 74.32%, you're not getting all that you could get and you're losing profit. Second example, in the Haber process, nitrogen gas is combined with hydrogen gas to form ammonia, so we can write the balanced equation from that information. And then we're given 100 grams of nitrogen gas and 21 grams of hydrogen gas, and we're told it produces 105.809 grams. Again, this is the actual yield. To figure out the percent yield, we need to know the theoretical yield, how much you could get. If you're given a quantity of each reactant, you have to first figure out the limiting reactant. So to figure out the limiting reactant, we're going to choose one reactant and then convert to the other reactant and ask the question, for the 21 grams of hydrogen, how many grams of the nitrogen do I really need? Do I need more or less than that 100 grams? And so we're going to convert 21 grams of hydrogen to moles of hydrogen, to moles of nitrogen, and then to grams of nitrogen. And the math says for 21 grams of hydrogen, I need 97 grams of nitrogen. Since I have more than 97 grams, the nitrogen therefore is in excess, and hydrogen is the limiting reactant. So now that I know that hydrogen is the limiting reactant, it is the one that's going to determine how much of the ammonia can be produced. And so there we're going to go from the limiting reactant, the 21 grams of hydrogen, to grams of ammonia. So if we go from grams to moles to moles to grams, we find that you can get 118 grams of ammonia if the reaction was 100% efficient. And so we actually got 105.809. The theoretical yield is 118 grams. So the percent yield again is how much you did get compared to how much you could get. The actual yield, 105.809, divided by the theoretical yield, 118 grams, times 100%, giving us 89.7% efficiency.